Hi everyone and welcome back to Activity 23. Today we are going to talk about our double angle identities. The double angle identities are used to find our trig functions at 2x from their values of x. The goal to use these is, again, kind of finding those values on the unit circle or using triangles similar to our sum and difference identities. So for each of these, for instance, sine of 2x, we have a formula here, 2 times sine times cosine. Cosine of 2x is cosine squared x minus sine squared x. And now due to the Pythagorean identity, and if we make some substitutions for cosine squared and sine squared, we also could represent this as cosine squared minus, 2 cosine squared minus 1, or 1 minus 2 sine squared. So cosine of 2x really has 3 different formulas. Kind of depends on the situation when we would want to use each. Last but not least, tangent of 2x is 2 tan x divided by 1 minus tangent squared. And again, these are actually being derived, which we'll talk about in class, from the sum and difference formulas. Now, if we are going to be using these to find triangle values, okay, these are going to actually be very similar to what we were doing yesterday with the sum and difference. You always want to draw your triangle in the correct quadrant, label the picture, and then plug in to the formula given. So we are given initially a third quadrant triangle, and the opposite is 2, the adjacent is 3. And in this case, they are both negative since we know we are in the third quadrant. And our goal is to find the sine of 2x, which we know is going to be 2 times the sine of x times the cosine of x. So essentially from the original picture, we need to figure out what the heck is the sine and what the heck is the cosine of this picture. So we need that hypotenuse value to be able to do that. So similar to what we've been doing to find the hypotenuse, we would take a squared plus b squared, aka in this case 3 squared and 2 squared. Remember the negatives will cancel, so I'm just going to write them as a positive so I don't forget that. 3 squared is 9, 2 squared is 4. So c is going to be the square root of 13. And that's our hypotenuse. So when we're listing our sine and our cosine, our sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And I could rationalize this, but I think I'm just going to leave it and double check that it doesn't just cancel out in my equation. So again, now I'm just going to plug those two values in. Sine of x is 2 over square root 13. Cosine of x is negative 3 over the square root of 13. And if you multiply these numbers on the top, 2 times negative 2 times negative 3 turns into positive 12. And again, we can just find that from multiplying. Square root of 13 and square root of 13 on the bottom end up canceling out, and we're just left with 12 over 13. All right, our next one here then is asking us about the cosine of 2 theta and the sine of 2 theta. And for our triangle this time, we are between 90 and 180, aka in quadrant 2. And they are giving us the cosine, so the adjacent over the hypotenuse. Now, when it comes to finding the cosine of 2x, again, we have 3 different options. And since they gave us the cosine, I'm going to choose to use the formula 2 cosine squared minus 1 because they gave this to me, right? And I could just plug that in from the get-go, negative 2 over 3 quantity squared minus 1. And then if I type that in, negative 2 over 3 squared minus 1. Oops, not 4, 1. And I'm going to turn this into fractions, so math, enter, enter. We get negative 1 over 9. So sometimes we didn't even really need the picture because they gave us that piece. Now for the sine of 2 theta, we have no choice. We have 2 times sine of x times cosine of x. And yes, we do already have, again, that cosine of x value is negative 2/3. Unfortunately for us, we don't have the sine value. So that is where we are going to need to find this y value over here using some Pythagorean theorem, a squared plus b squared equals c squared. 9 minus 4 is 5, and then square root of 5 ends up being our height there, over there. So our sine then is going to be the opposite over the hypotenuse, so square root of 5 over 3. So when we multiply for the top of our fraction, remember 2 is officially 2 over 1, so it's in the top. 2 times square root of 5 times negative 2 is negative 4 square root 5. And on the bottom, 1 times 3 is 9. This doesn't simplify any further, so that would be our final answer. All right, now as we move on to our last example on the back, okay, again, they are asking us for two of these different things. We want, again, the cosine and we want the sine. So again, this time they're telling us this is between 3 pi over 2 and 2 pi. So that is going to be in quadrant 4. And for the first one, again, cosine of 2 theta, we have some options. This time, one of them only involves the sine, which was given to us. So if we use 1 minus 2 sine squared theta, similar to that last example, we actually don't have to fully solve that triangle yet if we don't want to, because we can use the sine that they gave us. So 1 minus 2 times parentheses our sine value squared. And again, turn that into a fraction, math, enter, enter. We end up with 49 over 121. Now 2 sine theta is 2 times sine times cosine. So unfortunately for us, even though they gave us the sine, the opposite over the hypotenuse, we do need the cosine to be able to finish solving. Now our cosine, our x value, is going to be found by taking c squared equals a squared plus b squared. So 121 minus the 36 gives us 85. And then the square root of that, which is not going to really break down, is going to end up being our cosine. Or sorry, excuse me, our x value, which means our cosine then is our adjacent over our hypotenuse, so square root of 85 over 11. So in this case, 2 times negative 6 times square root of 85 is negative 12 square root 85. 11 times 11 is 121. Number 4 is for you to try. Okay, you are given the sine and you want to find cosine of 2x. Our last part here is a little bit of work with verifying. Okay, similar with verifying in previous lessons, we are given the goal. We want to make this happen. Okay, so in this case, notice this isn't a typo. We have cosine of 2x. Again, that is telling us we are using one of these 3 different formulas for this. Now, I noticed in my final answer that I have a sine, I have a tangent, so chances are I kind of want to use one of these that involves sine. So sometimes it's kind of tricky with the cosine of 2x, making sure you pick the correct one. Sometimes multiple of them are going to work. I'm choosing this time because, again, I see sine in my answer. I think this time I'm going to choose to use 1 minus 2 sine squared, and then see if from there, if that works out at all for me. And just keep this down here. So I'm going to make sure I distribute this negative through properly. So I have 1 minus 1, but plus 2 sine squared. And then all over my 2 here. 1 minus 1 cancels out to be 0. So I have, oops, and I forgot my cosine down here. So I have 2 over 2 sine squared over 2 cosine. 2's can cancel as well. And then remember, officially, sine squared is sine times sine. We have that cosine on the bottom. Sine over cosine can be rewritten as tangent. So we get that final answer that we wanted of sine of x times tangent of x. Our other verifying example, again, this time I'm going to choose to make the right-hand side my goal, and I'm given sine of 2x. So I know I can replace the sine of 2x with 2 times sine of x times cosine of x. These 2's can cancel so that I have 1 over sine times cosine, and then be careful of how my answer wants to be written. I need the cosecant on the top, the cosine on the bottom. So that cosine can stay, and the 1 over sine is going to become my cosecant on top. Keep that cosine on the bottom, and I verified that those are the same. All right, thanks everyone for watching. We'll work more at these in class.